Today, we're going to go over the backtracking problem, and we're going to go over it using generate parentheses question on LeetCode. This is a very common question asked in many interviews for bigger companies such as Microsoft, Facebook, LinkedIn, Amazon, etc. And I'll put all the companies that actually ask this question, I'll put it on the side so you guys can take a look at it so you guys know how important this question really is. So the generate parentheses question can be done in multiple different ways. You can use stacks, queues, trees, etc. But we're going to use backtracking to actually do this problem so that you guys can actually understand how backtracking is used, and it's a very useful method to actually know. You can use it again and again, and it's very useful for permutation problems, combination problems, for strings or for numbers, etc. So whenever you come across those kind of questions where you have to form multiple different combinations of a particular string or a number, backtracking is something that you should default back to and try to think about how you could do it using backtracking. Like I said, there are other methods as well, but once you understand backtracking, I'm hoping that you guys find it easier to use it more and more for interview questions. So let's go about actually doing this problem. This problem says, given n pairs of parentheses, write a function to generate all the combinations of well-formed parentheses. So to actually go about this problem, the first thing we're going to do is we're going to make the function called backtracking, which will actually start off our entire backtracking process using recursion. So let's go ahead and actually do that. In our backtracking function, which is right there, we're going to have to give it a certain initial input parameters, and in this case our input parameters is going to be an array itself, because we need to take all these combinations of valid parentheses and put it into a list. So that list is, we're going to call it array, and we're going to take all the valid strings that we produce of valid parentheses and put it in. So let's go ahead and make that. We're going to have the actual string which holds the valid list with the valid set of parentheses. We also have to have a counter which maintains a count of the total number of opening parentheses we have and the total number of closing parentheses we have as well. And at the end, we will have to pass in the initial input parameter we get, which is n, because n is going to help us identify when our goal is hit or not. So there you go, you have a function definition for our backtracking problem. Since we have gone over the three things you need for a backtracking problem, so let's go over the first thing we need. We need a goal. We need a base case which actually tells us when to stop this entire recursive process and when we have hit our goals. To actually make our goal, we're going to define a base case to when we should actually stop this entire recursive backtracking process, and when we actually have got a string which is the correct string and which is valid as well. If n is equal to 3, what they're basically telling you is that you have to have 3 opening parentheses, and for every opening parentheses we also have to have an equivalent amount of closing parentheses, right? So if n is equal to 3 and you will have 3 opening parentheses, you will also have to have 3 closing parentheses. The total length of a valid string has to be n times 2. So let's go ahead and do that. You're going to take that string and append it to your final array. So over here you've set your base situation and you have actually defined when you should stop your entire recursion. Now, part 2 of this process is actually defining your decisions at every step. And based on that decision, you're going to call your backtracking process again. Step in this entire process, we're going to have the decision to either make an opening parentheses or we have the decision to make a closing parentheses. Now, we have to figure out when we can actually make these 2 parentheses. So we're going to talk a little bit about constraints here. The only number of opening parentheses you can have is n opening parentheses. So if n is equal to 3, you can only have 3 opening parentheses. As long as the total number of opening parentheses you have is lesser than n, you're fine. You can make an opening parentheses and call the backtracking process again. At this point, when we pass in our total number of opening parentheses, we have to add 1 to the total number of opening parentheses, so our program actually knows that you have added 1 opening parentheses. Now the second decision you're going to make is you can make closing parentheses. but you can only make a closing parentheses if you have the more number of opening parentheses. So there you go, that should set our last decision case. Now we have made our backtracking function, we have set the goal for it, we have also set the appropriate decisions for it, and we have set these decisions based on some constraints. Now, every single backtracking problem is going to follow this exact pattern. So let's go ahead and actually use this backtracking function and see if this works. Before we actually check if this works or not, I set this as equal. You're supposed to add a plus here because you're adding a closing or opening to the valid string itself. So let's actually do that. There you go, it works, and hopefully you guys understood this problem. Backtracking, again, is a very useful problem. I understand that it could be a little difficult to learn, but the more and more problems you do based off backtracking, the easier it gets to actually use it in an actual interview setting with pressure applied based on time constraints itself. I'm going to come out with a new data science video, so keep an eye out for that if you guys are interested. So for example, you're given n is equal to 2. To begin this problem, we have 2 opening parentheses and 2 closing parentheses. At the start of our process, which is right here, we can make decisions. And the 2 decisions we defined earlier was that you can make an opening parentheses or you could make a closing parentheses. We cannot make a closing parentheses because the constraints associated with that decision was that we need to have more opening parentheses currently available to make a closing parentheses. But we haven't even made a single opening parentheses, so we cannot make a closing parentheses. But we could go for another decision, which is making an opening parentheses, because the only constraint associated with making an opening parentheses is that the total number of opening parentheses does not exceed n. Since we don't have any opening parentheses, we have not exceeded n, and we can go ahead and make an opening parentheses. Every time you make a decision, you should also update your counters. So in this case, we have used 1 opening parentheses, so we can make our opening counter as 1. And we have used no closing parentheses, so we can still leave our closing parentheses as 2. At this point of our process, we can make decisions again, based on our constraints. The question is, can we make an opening parentheses? Yes, we can, because we have only used the 1 of our opening parentheses. We still have 1 left, and it's still not exceeding n. We can go ahead and update our counters as well. So we've used up both our opening parentheses, so the opening parentheses counter becomes 0, and we have used none of our closing parentheses, so the closing parentheses counters remains as 2. At this point, we could also make a closing parentheses because we have an associated opening parentheses, so we can go ahead and make a closing parentheses. And we have used 1 of our closing parentheses, so you decrement the closing parentheses counter to 1. We can make decisions again. Can we have an opening parentheses? No, we cannot, because we've already used up all our opening parentheses and our counter for our opening parentheses is 0. We have 2 opening parentheses and we don't have a closing parentheses, so we can go ahead and make a closing parentheses. We can have an opening parentheses at this point because we haven't exceeded the total number of opening parentheses we can have. At this point, we cannot make another closing parentheses because in this string, we only have 1 opening parentheses and 1 closing parentheses. And if you remember, to make a closing parentheses, the constraint was that you have to have your total number of opening parentheses must be greater than the number of your closing parentheses. We can have a closing parentheses. You've made a valid set of parentheses string. So both of these now are considered to be valid parentheses of length n.